A lot of what we do in algebra or in analysis of functions is to learn how to solve or to find the zeros of functions. And part of that is knowing how to factor functions. And sometimes they won't factor, and so there are other things that we need to do. And so that's what we're going to be learning in these next few lessons, is how to factor our polynomials, and if they won't factor, what else we can do to help find those solutions or zeros. And so for factoring, we've already talked about how to factor quadratics. But today we're going to review factoring sums and differences of cubes. So a sum and a difference of cubes. Cubes being something to the third power. And so if you'll notice, when you're factoring out these cubes, whether there is a plus or a minus in the middle, the placement of these values is the same. We've got a, b, a squared, ab, and b squared. The only thing that changes is what kind of signs are in between. So that's how I'm going to go about going over this. You do need to just know these formulas for factoring sums and difference of cubes. So what we first want to do is figure out what is a and what is b. What's being raised to the third power? Well, here that's easy. This is just x that's being raised to the third power. But for 64, what number is that to the third power? Well, that would be 4 to the third power. 4 times 4 times 4 is 64. So that's the first thing. You want to identify what is it that's being cubed. And then you can just fill in the blanks in your formula. Because in the first blank, it says that we're going to put a. And a is whatever we got right here. So that would just be x in this case. And for b, we're going to put a 4. And in between, we're going to put a plus. And then in our next set of parentheses, we're going to fill in an a squared. In our case, that would be x squared. And then in the middle, we're going to do a times b. For us, that's x times 4, or 4x. And in between, there's a minus sign. And then in this last spot, we're going to put b squared. In our case, it's 4 squared, and 4 times 4 is 16. And in between there, we've got a plus. So the signs are plus, minus, plus. Whenever you have a sum of cubes and you want to factor it out, you're going to factor it out with a plus, minus, plus. All right, so in number 2, we've got x and 3. So we're going to do the same thing, except this time, when we're filling it in, we're going to use this formula because it's a difference of cubes. So we've got x and 3, but this time with a minus sign in the middle. Then we've got x squared. Then we multiply them together, 3x, and in between we've got a plus. And then we square this and we get 9, and in there we have a plus. So for a difference of cubes, it's always going to be minus, plus, plus. All right, for the next example, 8 is 2 to the third power, and then we have x to the third power, so it's just 2x raised to the third power. 125 is 5 to the third power. This one is a sum, so it's going to be 2x plus 5, and then we square this, so 2x squared would be 4x squared. Multiply these together, so 2x times 5 are 10x, and it's going to have a minus in there, and then square the last one, 25, and it's a plus. The sum of cubes is plus, minus, plus. And one more of those. 1,000 is 10 to the third power, so we have 10x and 1. So in our first parentheses, we've got a 10x and a 1. This one is a difference, so we're going to start with a minus. Then we square 10x, so that would be 10 times 10, or 100x squared. Then 10 times 1, 10x. And in between those, we have a plus. And then we square the 1. 1 times 1 is just 1. And in there, we have a plus. Minus, plus, plus for the difference of cubes. So just practice using the rules, and the more you practice, the easier it'll be to memorize. Now, some polynomial functions or polynomial equations that are raised to the third power don't necessarily factor out quite so easily. Not that they won't factor, but we might need some help in knowing where to begin, at least when we first start learning how to do this. And so that's kind of what this next part is about. We're going to see if x minus 1 divides into this polynomial function, because if it does, that means it's a factor, and if this is a factor, then if I set that equal to 0, I get x equals 1. 1 would be one of my roots, or zeros, or x-intercepts. So here's how this works. It's just like long division when you were in elementary school, so maybe we should review long division from elementary school real quick. So when you were in elementary school and you learned long division for the first time, you might have a problem like 36 divided into 4,292 or something like that. And so you would try to figure out how many times will 36 go into this number. And you started by looking at these first values. How many times will 36 go into 42? Well, you estimated it'll go one time. And then you multiplied. 1 times 36 is 36. And then the next step was to subtract. And then when you subtract, you got 3, 1, so we got 6, that's gone away. And the next thing you did was bring down the next number. Everybody remember how to do this? And then we estimated again. How many times will 36 go into 69? Well, maybe twice, but if I do 2 times this, I get 12, 1, 72. That's a little bit too much. So again, it just goes one time. So 1 times 36 again gives me 36, and I subtract. And then when I subtract, I get 33. I bring down the next number. And then I divide again. And when I'm thinking about how many times that would go in there, I know 36 would go up, 36 times 10 would be 360. So probably 9 times. So let's see, that'd be 54, 5, 27, 5, so 3, 24. All right, I think I did that right. And then we're going to subtract again. So borrow here, carry it over, 8. And so at this point, I don't know what they taught you about the remainder. I mean, sometimes people just said, okay, we'll just put R8 out here. That bothers me a little bit. There is a meaning to this number 8. 8 is what is left over. It's what, how many times we had, how many things we had left. And so it's a portion of our divisor. And so we have 8 over 36 left, which would reduce. But it is a fraction. This 8 over 36 is just a portion of what's left. And so some of you may have learned to put zeros out here and just keep dividing. What you get when you keep dividing, that decimal is 8 over 36. It represents the same fraction, that same number. So we are going to do something similar to this with our remainder whenever we have problems that have a remainder. But that's the idea, exactly the same thing we're going to do, except now we've got a few letters to deal with too. So we have 2x cubed minus 3x squared plus 4x minus 3. All right, so when we're dividing, we're going to take this first value and divide it into this first value. So x will divide into 2x cubed, 2x squared times. And if you're not sure about that, then think about it this way. 2x cubed divided by x. We're just taking that and dividing it by this. And this reduces down so that all we have left is 2x squared. That's all we're doing. Then we are supposed to, just like in elementary division, we're going to multiply this number times this thing that we were dividing by. So 2x squared times x is 2x cubed. 2x squared times negative 1 would be negative 2x squared. So the next thing that you do when you are dividing, even with the regular numbers, is to subtract. But when you subtract this thing, remember you're subtracting this entire binomial, which is also going to change the second sign. So don't forget to change your signs. So we're subtracting, and these go away. And I have negative 3x squared plus 2x squared would be negative 1x squared. And then we bring down the next term. All right, so we're going to go again. This time we're trying to figure out how many times will x divide into negative x squared. It'll go negative x times. Again, if you're not sure, just write it out here. Negative x squared divided by x. One of those goes away with that one, and I'll just have negative x. So negative x times x is negative x squared. Negative x times negative 1 is plus 1x. But then we're going to subtract, which changes the signs. So these go away, and I've got 4x minus 1x is 3x. And we bring down the next term. So we go again. How many times will x divide into 3x? It'll go 3 times. Or if you're not sure, 3x divided by x, x is divided out, I just get 3. So 3 times x is 3x. 3 times negative 1 is negative 3. And then we change the signs. And that is gone, and this is we have nothing left, no remainder. So this was a factor of the original problem. So this is going to help give us solutions when we get to the point where we're looking for solutions. All right, so it says, will the quotient factor again? If so, write it as a product of its factors as well. Well, the quotient is this answer that we got up here. So we can try to factor that. 2x squared minus x plus 3. If it will factor, it would factor into two binomials. So we know we're supposed to do 2x times x would give us 2x squared. And out here we'd need something to give us 3. So maybe 3 times 1. So it's looking promising. But in order to get a negative x in the middle, I'd have to have a negative 3x and a plus 2x on the outside. And a negative 3x plus 2x would not multiply to give me positive 3 on the end. So although it looked promising, this doesn't work. So no, this one doesn't factor again. But we still have a couple of factors. We have the original factor, x minus 1, times what we got as our answer in our quotient, 2x squared minus x plus 3. And if I were to multiply these back together, I would get the original problem. This 2x cubed minus 3x squared plus 4x minus 3. So this would be a product of the factors that would give me the original. All right, so we're going to try another one. So we have x plus 2, and we're dividing that into 2x cubed plus 3x squared minus 8x minus 12. So x will go into 2x cubed, 2x squared times. So 2x squared times x is 2x cubed. 2x squared times 2 would be plus 4x squared. And then we change the signs. And so these are gone. And I have 3x squared minus 4x squared, which would be negative 1x squared. We bring down the next term, minus 8x. Then x will go into negative x squared. How many times? Negative x. So negative x times x is negative x squared. Negative x times 2 would be minus 2x. And again, we change the signs. So this is gone. 8x, negative 8x plus 2x would be negative 6x. And we bring down the next term. X will divide into negative 6x, negative 6 times. Negative 6 times x is negative 6x. Negative 6 times 2, negative 12. We change the signs, and we get a remainder of 0. And again it asks, will this quotient factor again? So we'll try. We have 2x squared minus x minus 6. We're going to try to factor that out. So 2x times x, and then for 6, we're probably going to need to use 3 and 2, and we want to get a negative 1 in the middle. So I'm going to do this way. That would give me a 4x here and a 3x here. And if I need a negative x, I need negative 4 plus 3. So to get a negative 4 out of this, I have to put a negative here and a plus 3 here. And that would multiply to give me negative 6. So it looks like, yes, it does factor again. It factors to 2x plus 3 times x minus 2. So then it says express this original problem, the top, as a product of all of its factors. So we have the two factors that we just got, 2x plus 3 times x minus 2, times the original factor, which we found when we divided out was x plus 2. If I multiply all of these things back together, I get this original problem. All right, we have one more example here. And in this one, you'll notice that the degree changes. Like there's some things missing here. And so for every piece, for every exponent that is missing, like it goes from the 5th power down to the 3rd. So for the x to the 4th power, we're going to put in a 0. And then here it goes from x squared down to a constant. So in here we're going to put a 0. So here's what it's going to look like. Same with our divisor. We're going to put x squared plus 0x minus 3 divided into, and then we got x to the 5th plus 0x to the 4th minus 3x to the 3rd plus 8x squared plus 0x minus 24. So everywhere that we were missing a term, we're going to put in a 0. Now for this particular problem, I don't think it would have mattered, but for some problems it makes a big difference. And so it just lines everything up a little bit better if you'll hold those places. But we do the same thing. We're going to look at the first term. Divide x squared into x to the 5th. It'll go x to the 3rd times. So x to the 3rd times x squared is x to the 5th. Remember, when you're multiplying, you add the exponents. And then x to the 3rd times 0x is going to give me 0, x to the 4th. Then x to the 3rd times negative 3 is minus 3x cubed. All right, so then remember we have to subtract, which changes our signs. So we've got minus, minus, plus, and that goes away, and this is 0 already, and negative 3 plus 3 goes away. So all of that is gone. So I need to bring down all of these things because I don't have anything left to divide into. So I'm bringing down 8x squared plus 0x minus 24. All right, so x squared goes into 8x squared 8 times. So 8 times x squared is 8x squared. 8 times 0x is 0x. 8 times negative 3 is negative 24. And we change all the signs. We subtract. And again, all of that is 0. So we got x cubed plus 8 as our quotient, and so it wants to know, will the quotient factor again? So x cubed plus 8. Well, that's what we just went over in this lesson. This should factor again. It's a sum of cubes. So we're going to use our little formula that we talked about in the first part of the lesson. This is x and 2. So we're going to put x and 2 with a plus in the middle. We square the x. We multiply these together. And in between it's plus minus. And then we've got plus, and we square the last one, 4. So yes, it does factor again. It would be x plus 2 times x squared minus 2x plus 4. And then it wants the original problem as a product of its factors. Well, the original was this is what we divided by first. So it was our 2 factors that we have now times x squared minus 3. And be careful too, because when it asks for the product of factors, look at the one that you were using to start off with. If this had been like an x squared minus 4, that would be a difference of squares, which would factor again. So any of these terms that will factor again, you would want to factor them when we're talking about a product or a list of all of the factors. But in this case, this is it. None of those will factor again.